efficiency standards over the last 20 years have been steadily increasing. There's no doubt about that. And this is very much to ensure that we can meet our carbon reduction targets set out for 2030. Internationally, we find that manufacturers and designers are focusing very much on products that could be applied to energy savings within buildings, and also products that can satisfy requirements in building automation to make efficiencies.
We have, inverter technology with compressors, which enables us to get more efficiencies from the systems. And that runs into the heat pump market now, where we've got large commercial heat pumps, which are suitable for district heating applications. And there's always a drive for meeting targets with manufacturers, which enables us to meet the new legislations going through. And this has pushed the need for, with net zero and global warming, it's pushed a really important need to reduce the existing building stock within the sector.
Well, as we know, about 50 to 60% of all the energy that is used is to heat and cool buildings, which is an enormous amount. Building automation technology allows integrators to fine-tune control systems so they can make efficiencies and decrease the energy use across buildings globally.
The use of our ultrasonic and electromagnetic flow and energy monitoring systems are pivotal for optimizing this plant. If you have a large 500 kilowatt heat pump, for example, if this is running over capacity by maybe only 5 to 10%, the running costs are considerably higher, and we can help to get the optimization engineers to reduce that running capacity in turn over many buildings. That will reduce our carbon footprint significantly.
The initiative to have the EU net zero by 2050 is hugely relevant to the HVAC building services industry, as a great majority of the energy that is produced is used in buildings to heat and cool. New projects involving retrofitted systems and plant optimization are set to see a 50% increase to meet the 2050 targets.
Optimizing existing plant portfolios, replacing old, outdated fossil fuel technologies with new efficient heat pump models and improving control systems is paramount to achieving that 2050 target. Local politicians, talks I've been to have repeatedly told the industry that they need us to play a pivotal role in designing these systems and retrofitting existing systems for the targets to be met.
We've seen for some time now an increase in the standards that are being applied to buildings. And the MEES is just another step along that path. It is also a concern to landlords in terms of lettings. And so it's very important that they apply improvements to their systems generally. And part of that is utilizing flow and energy metering, and also improving water quality standards across the board.
Badger meters, flow instrumentation, so the ultrasonic flow meters and electromagnetic flow meters with the control protocols play a pivotal role in this, because the energy performance certification, which is presented to the commercial building at the end of either a retrofit or it's a new building in its entirety, it is essential now, and this message needs to be communicated correctly by the specifiers and designers, that for the systems to maintain their efficiencies and to score the right grading, which will obviously need to be Band C in 2025 and Band B in 2030, we need to know what the design flow rates are for the wet heating or cooling circuits, and we need to have high and low alarm limits implemented into the building management system. The inspector at the time will look for that, and that helps the building owners achieve that target. Without hitting the targets, the buildings are very difficult to let, and also the commercial value drops.
Retrofit is extremely important, especially in buildings. Typically, it's very costly or not possible to drain systems. And so retrofit devices that can be either clamped onto the outside of the pipe without shutting the system down or making any pipe changes is really important.
You can actually get real-time flow data and energy data and feed that back to the system's controls. That enables the optimization engineers to adjust the pump speeds and the compressor speeds and the capacity. So this is all about making sure that systems aren't running over capacity and getting a real-time sight of what the flow rates are. We've seen many projects, optimization projects, where there's been huge success with minimal outlay and shown a huge return on investment very, very quickly by just, for example, a 50 kilowatt inverter pump. If you reduce that by 30%, that is a huge saving over the period of 12 months. Water quality monitoring, or what we would call real-time water quality monitoring, where we're collecting data from the water circuit, the closed loop or open loop circuit, is a massive benefit towards the drive towards sustainability. In my career, I have seen too many systems with very poor water quality, and the ongoing result in capital expenditure with failing components because of build-up of secretions and scale within the system has been a problem for many years, and there's water quality inspections that take place on critical sites, but it often doesn't capture the true nature of the problem.
The Badgermeter Metrinet water quality monitoring solution is a real-time online measurement of water quality, which allows building operators to move away from having to do spot checks, sampling, which can also be very costly. And also, because it's so intermittent, it doesn't allow facilities managers and building tenants to be able to actually monitor the quality of the water in real time. This is important because system failures can happen very quickly. So what we're trying to look at here is the prevention of corrosion, which can also have an effect on components within the system, and also degradation of the water quality generally, which can lead to biofilm buildup and also potentially Legionella. The ModMag electromagnetic inline flow meters play a crucial role in the design of HVAC systems. These devices are full bore designs and there's no moving parts. So typically in many HVAC systems, there might be an orifice plate, which is a restriction within the flow, which creates a huge amount of energy requirements to pump the liquid through. Whereas mag meters, not only are they very accurate, but also they don't have a pressure drop over their bore, which is very important in not only energy efficiency, but also because they have no moving parts, they will maintain their performance over many years within a system.
As long as the flow is conductive, the product works perfectly well. And that enables, via the control protocols with the BACnet, which is BTL certified, which is a big bonus for the integrators. The information enables the accurate, specific commissioning required for the plant within these new buildings on design.